Hello friends and welcome. So this video is about the determinant of 3 cross 3 matrix, but the determinant of 3 cross 3 is a very complex method for which we have to first understand some of the terms and we have to understand how to calculate some things for calculating the determinant of a 3 cross 3 matrix. In this video, we are going to cover two basic things: calculation of the minor of the element and the cofactor of the element. And we are going to learn how to calculate the minor of the element and the cofactor of the element. We have covered all the operations regarding matrices in our previous videos, which include the determinant of a 2 cross 2 matrix, and that was a very easy method. But 3 cross 3 contains some different method or strategy for which we are going to find the minor of element and cofactor. First, friends, let's just take a 3 cross 3 matrix. I am just taking a generic 3 cross 3 matrix, which is composed of, let's suppose I am taking this A represent any number. And here we have to position it 1 1, that is first row, and then first column, that is 1 2, first row second column, 1 3, first row third column, second row first column, second row second column, second row third column. Then we have third row first column, third row second column, third row third column. Here this first number represents the row and the second number represents the column. So this is how a 3 cross 3 matrix can be written as generic. So for the minor of a matrix, first we are going to learn how to calculate the minor of an element. Suppose this is an element. These all are different elements that compose a matrix. So we have to find how to calculate the minor. It is represented as capital Mij. So it is represented by the capital M, which in base here it is I and J. For I is the row and J is the column. So that means for the minor of an element, we have to just drop the row and the column, the specific row and the column. Let's suppose if I'm taking, this is a 3 cross 3 matrix and I have to take the minor of, suppose, this number, that is A1 1. So that means here 1 1. I have to drop the first row and the first column. That means these elements are excluded and the rest of the numbers are going to be taken. In this way, we have to calculate the minor of any element. Let's take another example. Suppose I have to take a minor of, let's suppose, 2 3. That means second row and third column. Here it is the number, so it means I have to exclude that column along with that row. So the left of the elements remains. In this way, we are going to calculate the minor of a matrix. Or let's take an example and then. So friends, for example, I have taken a matrix that is a 3 cross 3 matrix and we are going to find some random element, minor of elements. Let's suppose we have to find the, so we are taking the first element. Here the first element represent as E11. So for the minor we have to write M11. Here 1 is the row and 1 is the column. For the minor, as we have discussed, that it is the dropping of the row and the column. So we are going to drop this row and this column and the remaining elements left. So we are going to take the determinant of these remaining elements, that is 5, 4 and 8, 9. And this determinant is so easy to calculate. We already discussed that it is the product of the diagonals and then we have to subtract them. So 5 9s are 45 minus 4 8s are 32 and 45 minus 32 equals to 12. 13. Let's friends, we have to calculate the minor of this number. So as per this number is 2 1. Okay, let's suppose this is the simplest one. Let's suppose we are going to take the minor of this one, that is A22. That is the second row and the second column. For the minor, we have to write M22. So for this, we have to draw the column and the row. So the remaining elements left is 1, 3, 7 and 9. So here we have to calculate it. The simple determinant method, that is 1 multiplied by 9 minus 7 multiplied by 3, which becomes 9 minus 21, which is equals to minus 12. So friends, in this way we are going to calculate the minor of an element. That means we have to draw the row and the column for which element we are going to calculate the minor, and then we have to write the rest of the elements into a matrix form, and we have to calculate the determinant by the simple 2 cross 2 determinant method. So in this way, we are going to find the minor. That is a must thing while solving a determinant of 2 cross 2. Now moving toward the cofactor of an element. So friend, moving toward the cofactor of an element, when you have to find the cofactor of an element, whatever be the element, it is written as the capital A, then the number of row and column, and the formula is -1 into the addition of the row into column and then the cofactor. So this means we have to take -1, and the power is the row into column, the addition of the sum of the row into column, and then we have multiply it with the minor of an element. Suppose I have taken 1 1. It is the simplest example. So that is the element, that is the first element of a matrix. So we are going to find the cofactor, that is A11, which is equals to -1 as per the formula. And here the number of the value for the row is 1 and the value for the column is also 1, and then we have to write the cofactor, minor. And here -1 power 2 MII. So whenever a negative value have an even number in its part, it becomes positive. So we can say the cofactor of this number is equals to the minor of the same number. It is going to be equal to the minor. So if the sum of the row into column is equals to, it is a positive integer, then the cofactor is going to be the minor of the element, and if it is not the even integer, then it is going to be the negative of the minor. Let's take an example of the negative cofactor. Let's suppose I am taking here 1 2, A12. For A12, same method, -1 into for I we have value 1, and for J we have value +2, and here the cofactor of the same number, that is 1 and 1 2. So here A12, it becomes -1 power 3 and then M12. Here the power is 3, so it remains as minus, so it becomes -1 2. That means whenever the number or the sum of the row and the number of row and the column is even integer, the cofactor becomes the equals to the minor, and if the sum is an odd number, then the cofactor becomes the minus of the minor of the elements. So friends, this was important to calculate the minor and the cofactor, because in next videos the determinant is totally based on the cofactor and minus, and we will going to learn how it is useful. So as for the signs, we can say if we have a 3 cross 3 matrix, then the cofactor, the matrix sign must be as plus minus plus, minus plus minus, plus minus plus. So this will help in finding the determinant along with the you can say the adjoint of a matrix. So we will just going to understand the how to calculate the determinant in the next video. I hope you find this video knowledgeable and you have completely understand the concept of the minor and the coefficient. Till then, take good care of yourselves and stay blessed.